All right, hi science students. Today I'm going to need a protractor, something like this will do, and 3 highlighters. So we got a blue, yellow, and a green. So our essential question for today, EQ, is what causes seasons? And then off the top of your head, just write down right here, take a guess. What do you think causes seasons? You don't have to look up on the internet or read anything. Just take a guess. What do you think causes seasons? Pause the video and write that there. Okay, what did you come up with? All right, we're going to do some diagramming on this lesson. Seasons are really cool. They're also pretty complicated, but we'll figure it out. So if we draw a circle like this, oops, pen's running. There we go. Let's think about the Earth. We've got the Earth, and the Earth is half lit up with sunlight. So take our yellow, we've got the sun hitting half of the Earth at all times with heat and light and keeps us all alive. Okay, another thing we got going on is that let's light up half of it. Half of the Earth is lit up. Also, let's imagine there's a pole or a stick going thousands of miles through the Earth, just like a globe in class, and the Earth is spinning on this axis. So this is the axis, and the Earth is spinning or rotating on this axis. So we got half lit up and it's spinning. Okay, there's more going on. Let's do another little sketch here. We've got the axis. We've got it half lit up in sunlight. It's spinning around counterclockwise. But also, okay, if we were just flying through space, you know, spinning up and down, things would be a lot more regular, but they're not. The Earth is tilted. It's tilted this way, and it's tilted that way. That makes our axis tilted, like this. So we have a tilted axis, and the tilt is very specific. Let's we're going to color code these angles because it's just easier to think about it that way. And that tilt is at 23.5 degrees. Okay, we're flying through space. Half of the Earth is lit up. We're spinning around, and we're also tilted. Okay, so let's add one more question to this. So let's say we take our model. We've got an Earth here and an Earth here. Let's say here it's January. And let's say over here it's July. Winter, summer in the northern hemisphere. And let's put a little sun in the middle here. And let's get some light going on here because sunlight just makes this all happen. We've got half of the Earth lit up here. We've got the sun giving off heat and light, keeping us alive. And then we've got the other half lit up over there. And what's the Earth doing? The Earth is orbiting around the sun. We're going about 66,000 miles per hour through space. It's amazing. And we're going around 365 days a year. And let's think about distance. So how far are we from the sun? All right. So in January, let's write a distance here. This distance is 91.4 million miles. 91.4 million miles away. Okay, let's look at July. Now, would we be closer or farther in July to the sun? Write down what you think. Would we be closer or farther from the sun in July? I mean, how does July feel compared to January? All right, did you write down something? Okay, in July, we are 94.5 million miles away from the sun. That's kind of weird. I mean, think about that. That's a 3.1 million mile distance. We are 3.1 million miles closer to the sun in January. Why do you think that is? That's different than I had thought. Okay, we're going to learn a little vocabulary here. When we're closest to the sun, that's called P-R-I, helion. Helion means sun. And then when we're further away, it's AP, aphelion. Okay, those are two vocab words for us, along with axis, rotation. Okay, let's keep going here. So let's do another, let's add to our model. We'll put a sun here, and then down below here. We're going to use a protractor today, so let's put a protractor in there. And let's keep going. Let's say our sun moves down a bit, and let's have our protractor again. And then let's do our protractor one more time, and let's have the sun down around here. Again, it's gone pretty far from where it started. And let's say we're imagining here, but when we're using our protractor to study angles, seasons are all about angles, and we're imagining this is the surface of the Earth. And then we've got the sun here, the sun here, and the sun here. Now the sun is going to hit the Earth at different angles here. So when the sun is directly overhead, and this would be in the summertime, the angle comes down and hits the Earth like this. Then the Earth goes a little further. Let's say in the spring we go from summer to fall. This fall the sun is going to be more like this. If you go out and look at the sky, it's really neat because you can see the angle of the sun changing and shadows get longer. Then in the winter, shadows are even longer and it's colder. And let's label these angles. So first we got the this one here. This would be a 90-degree angle. And then the next one here, as we go down further, we get into fall after our summer here. This is going to be 66.5. Getting lower, less intense. Then as we get further down, we get 23.5. So in the winter, there's a very low angle. The sun is very south in the sky. And we're going to label the angles this way. So right now we're going to pause. And we're going to do a light activity in another short video. It's kind of fun. And I'll see you when that's over. And we'll get back to this note page.